Hey guys, Kira D here. Welcome to my home garage. Now that we are all stuck inside and dealing with all this craziness going on in the world, I thought that I'd have a little bit of fun and do a STEM demonstration for you, but do it virtually. So if we don't remember what STEM stands for, it means science, technology, engineering, and math. Now, one of the coolest parts about my job working for Universal Technical Institute, Motorcycle Mechanics Institute, and Marine Mechanics Institute, as well as NASCAR Tech, is I get to do these STEM demonstrations and talk about how that science and technology and engineering and math applies in our different industries that we support, right? So one of my favorite topics that we get to talk about today is fuel, because fuel is what gives us our power inside of our engines. So most important thing that we got to remember is when we go to start a vehicle, in order to have that engine turn over and be able to produce that power, it needs to have fuel and air mixed together, sucked inside that engine, compressed. That spark plug needs to ignite that air and that fuel to explode that explosion of air and fuel inside that engine and produce power and torque, basically. Now, we are not going to talk about internal combustion engines and what's happening and why it's happening. We'll talk about that a different day. Cool stuff, I know, but we're going to talk about that a different day. Today, what we're going to talk about is the delivery of that fuel, mixing with that air, and why that's important inside of that engine. Now, when we hear a vehicle starting up, and we hear that engine starting to turn over, and it's sucking that air and that fuel inside that chamber, when it actually starts, you can hear that whoa, right? And that's when it's starting to produce that explosion, making that combustion happen and producing that power. Now, to give you guys an example of what we're talking about, I'm going to start up this CBR 600RR because I love motorcycles and I want to. All right. Way cool, fun stuff, right? But what we're going to talk about is the delivery of that fuel into that chamber. Now, modern motorcycles like this utilize a delivery system called fuel injection. Back in the day, we didn't have fuel injection. And one of the first delivery systems that we're going to use today for this demonstration is a carburetor. Now, today, I'm going to use this little carburetor. This is a Mikuni. This is a VM3233. This little sucker, as you can see, is pretty simple. So, should be pretty easy for this demo. Now, the one thing we got to remember is when we go to fuel up our vehicles, we are putting raw gas, liquid gas, into our gas tanks, right? So we got to get that fuel down from our gas tanks into our float bowl. And this float bowl fills up with that fuel. Now there's mechanisms in here to be able to control that flow, but once it fills up this float bowl, it allows that fuel to then be mixed with air. So we're pulling outside air from the atmosphere through the front of this carburetor, and we are mixing it with that fuel. And you can see this slide moves up and down inside this carburetor. So as it opens, and it allows more air through this carburetor, there's also a little needle on the bottom of that slide that allows for more fuel to be mixed into that air-fuel ratio. And I'm going to show you what I'm talking about. So this is actually one of those little slides. And as you can see, as it moves up and down, this needle also moves up and down to regulate how much of that fuel comes out of this float bowl. So as this is open and it's all the way up, you can see that this needle is also all the way up, and it's allowing more fuel because there is less resistance from this needle because it's little on this end, right? So more fuel can come out into that air mixture. As we have less air and this starts to close, we see that there is more resistance because this needle is a lot fatter on the top side, right? So not as much fuel is going to mix with that air. That's a great way to help regulate how much fuel mixes with that air. In addition to that, the one thing that it does is it interrupts the fuel flow. So, to show you what I'm talking about, right? We are going to use this spray bottle, right? Now this spray bottle has a float bowl. It has a long tube inside of there that goes up to the nozzle, and if we spray, we can see that there is a stream Now, because this is pretty far open, the stream's pretty big, right? So it's pretty much at the little end of that needle right now. If we add more resistance to that flow, we can see that it changes it into more of a vapor form, right? So it's a lot thinner, and that's exactly what we want to do with our fuel. So you got to think about this, right? The closer to a vapor status that we can get that fuel as it mixes with that air, the better it's going to burn. When you think about dumping a big old pile of gasoline on the ground and you go to light it, the gasoline, the fuel itself, doesn't burn. It's actually the vapors on top of the gasoline that burn. So we want to get that gas as close to that vapor status as possible. Now, when your vehicle is cold and you have cold air and cold fuel and the inside of your engine is cold because it hasn't turned over, it hasn't started running, those combustions haven't started happening, those explosions aren't creating heat yet inside that chamber. So everything's pretty cold. Cold fuel is really hard to vaporize because it's a lot heavier and denser. It's got more oxygen in it, right? And as it's coming through here and it's coming out on this side as it mixes with this air, right? That fuel is actually condensing and it's sticking to your intake manifold. So you lose some of that fuel. So when you're first starting your vehicle up, you need to richen that air and that fuel ratio. So you need to add more gasoline. The cool thing about this little carburetor is that it has a enrichment circuit that can be turned on by moving this lever, right? So you can see this lever moves up and down. So when you engage that enrichment circuit, it gives you the opportunity to temporarily add more fuel to your air and fuel ratio. And once your vehicle is up to operating temperature or is running okay on its own, you can close that. And now you are back to your normal air and fuel ratios that you need inside of your engine to run and run efficiently. So it's a great temporary way to add that fuel. So this enrichment circuit is like a little carburetor inside your carburetor. It's cool. Now, when you pull this lever, you can see this plunger lifts up, right? As that plunger lifts up, it allows for this port to become open. And it allows fuel from this flow bowl to move up into that port as air gets sucked through this additional little port on the front end. So you still have your main stream of air and fuel, but this little port here allows for that additional air to mix with that little bit of additional fuel, atomize that fuel, and blast it through this side. Now I have a carburetor that's all torn apart to be able to show you what I'm talking about a little better, okay? So this sucker here is all torn apart. As you can see, my lever, my plunger is up, this port is open, and on the bottom in this flow bowl, you can see that tiny little port right there. That is where that additional fuel is moving up into this chamber, and this air, which is marked by this wonderful red zip tie, this little port, allows that air to move in, and it atomizes and blasts that air and that fuel mixture out on this side of your chamber and adds to that original flow of air and fuel, increasing the amount of fuel that you need when you go to start your vehicle. Now, some of you might be going, you know what, you use this word atomization. What does that mean? I've never heard of that before. Atomization, my friends, is awesome. Now, when we talk about something becoming a vapor, it's a lot easier to create a vapor when you have heat. When you have no heat because you're basically starting a cold engine with cold fuel and all this cold stuff, right? And you don't really want to add any more heat to what's going on inside your engine, because once it starts to warm up, you are going to create a lot of heat from that explosion, right? That air is going to create heat. That compression of that air and that fuel is going to create heat. So you really don't want to add more heat to that process. So atomization allows us to take that liquid, raw liquid, like so, and use a process where you can see if I pour this liquid, we have a stream. If I move this up and elongate that stream, you can see that it starts to break apart, right? and it actually atomizes that liquid. So as it's breaking it apart by elongating that stream, it's creating smaller droplets of that liquid that can then be added to that air, and it can be more efficiently burnt and combusted inside that engine because it's closer to a vapor status. Way cool, right? Way cool. Now, when I mentioned to you earlier that you have a cold air coming into the engine, when you are producing power from your combustion inside your engine, it's really important to have a certain amount of air and a certain amount of fuel, right? Cold air has more oxygen in it. So if you can deliver more cold air, you can deliver more fuel, because oxygen is what's necessary to create fire, right? To create explosion. So in order to have that explosion to happen, you need to have oxygen, right? Anybody who's lit a campfire knows that. You're blowing on it, right? You're trying to increase the amount of air that's going into that fire so that it will burn, right? So it's really important that you maintain the right mixture, but you want to take advantage of that cold air when you have it. So a lot of times in performance vehicles and drag cars and that kind of stuff, as they're going down the strip, they got those big, huge cold air intakes because that cold air has more oxygen in it. And so now it can deliver more fuel and have a better, more consistent combustion because the temperature is easily regulated inside that engine. And you have more oxygen in it. So I'm going down a completely different path. I could go on and on about this stuff all day because I love motorcycles, I love riding motorcycles, but I also like to talk about them. So I'm going to stop for today. I hope you guys enjoyed the STEM demonstration. You can see how science, atomizing that fuel and mixing it with that air, can create a better combustion situation. How math, it's super important to have that air-fuel ratio and make sure that it happens at the right time, really matters, but also the engineering behind it is an amazing feat, right? And it's super cool to see today's technology like fuel injection to be able to help us overcome some of those older situations and different types of models that we've had in the past. Be able to do this process more efficiently with technology today. So if you guys want to check out more STEM demonstrations, I'm going to be doing more in the weeks moving forward, so please check back in. If there's stuff that you want to talk about, or if you have questions, on the bottom of this video right here, leave me a comment, ask me a question. You know, we're all here to be able to enjoy these topics and to have something that gives us some fun and some different ideas while we all have this time to be at our home. So I'm glad that you guys joined me today, and I will see you next time.